Good morning and welcome, everyone. Please take your seats as quickly as you can. I hope your ICME started well yesterday and that continues today and for the rest of the week. I have a few quick items. We're still trying to find out about the welfare of the dancers from yesterday, and as soon as we have any news, we will pass it on to you through the app. If you have any questions or concerns in the building or any other matter, please go to the registration desk. That's the best place to get assistance. I need to say that we have a zero tolerance for bad behaviour towards staff or each other. It will not be tolerated. Other than that, all housekeeping messages will come to you through the app. You won't have to put up with me at the start of plenary sessions. Conferences like this are made much better through the support of sponsors who partner with us. And we thank all of the sponsors that we have for ICME 15. At this stage, I'd like to introduce Barry Kassane, who will say a few words on behalf of Casio, who are our gold sponsors. Thank you, Barry.
Good morning. I'd like to start by acknowledging that we meet on the land of the Gadigal people of the Eora Nation and pay our respects to their elders, past and present, and to all other First Nations people who are here. Welcome to Australia and welcome back if you were here in 1984. This trade display is an important place where mathematics educators and the commercial world work together to improve mathematics education. An important part of any Congress. Casio have asked me to welcome you to their stand and invite you to boost your curiosity. ICME 5 in Adelaide was a very different world. Pre-internet, almost pre-email, pre-World Wide Web. Scientific calculators were around, and so were microcomputers, as we called them at that time. Since then, there have been many remarkable developments in technology, increasingly evident in some schools around the world. Some of these are problematic and widely understood as disturbingly distracting, like the mobile phone has been for many of us. I continue to be excited about scientific calculators, however. I'm both familiar with and experienced with many other technologies proposed for use for teaching and learning mathematics. Scientific calculators used to be tools for scientists and engineers doing arithmetic efficiently. 40 years of development has changed that completely. So they are now purpose-built mathematical environments for school mathematics education designed to support student exploration and learning and teaching. They are widely affordable around the world, easy to use, don't need electricity, recharging or updating, or a Wi-Fi network, or even an IT department. They're small enough and light enough to carry around from home to school, from class to class, and even into examinations in most countries where they're permitted. They don't distract students endlessly, as the internet, social media, smartphones and laptops all too frequently do, despite the best efforts of teachers and parents. You mightn't know, but less than half of the world's 8th grade students do mathematics in a classroom where they have access to a computer. But most importantly, scientific calculators these days are packed with mathematical functionality to deal with all sorts of numbers, functions, equations, numerical differentiation, integration, data analysis, probability simulation, and lots of other stuff. And that's no accident, as Casio has relied on mathematics teachers throughout the world to help them decide what capabilities are most important for their students. In fact, in my view, calculators like the new Casio ClassWiz range are more correctly described as mathematical calculators. Let the scientists and the engineers look after themselves. Many people are unaware of these changes. We're too occupied with other things. So Casio are offering a number of short, hands-on workshops on their stand during the Congress for you to learn about them, how to use them, and try them out for yourself. I invite you to take this opportunity to boost your curiosity and look forward to seeing you there. Thank you.
Thank you, Barry, and thank you to Cassio. We now move to the start of today's professional program, and I'd like to hand over to Professor Nuria Planas-Raig, who will chair this session. Thank you, Nuria.
Good morning, everyone. I'm Núria Planas from Autonomous University of Barcelona, and it's my pleasure, my great pleasure, to introduce to you our plenary speaker today, Professor Rina Zazkis. The challenge of introducing someone is big. What can I say to introduce Rina that she could not say it better herself? I might add something personal, such as my admiration for international scholars, international academics like her. Rina Zazkis is Professor of Mathematics Education at the Faculty of Education of Simon Fraser University in Canada, where she owns a prestigious Research Canada chair in STEM teaching and learning. She's, as you all know, she's the editor-in-chief of the highly influential Journal of Mathematical Behavior. She was the recipient in 2019 of the Mathematics Ambassador Award, and on and on and on. The University of Haifa saw her academic beginnings, and since then her research journey has been focused mostly on undergraduate mathematics education and the development of the content knowledge of mathematics of pre-service teachers. Other important research that she has also conducted has been on the teaching, the learning, the teaching, and the understanding of elementary number theory. And there is more than you can read on her website, which I highly recommend. Her vitae is, at the least, most impressive. So more reasons for not going into a long introduction. Life is too short, so let's ask Rina to stand up and start talking. Thank you very much, Rina. The floor is yours.
Thank you very much, Nuria. Thank you very much for introducing me. When somebody asked what is the most important thing about me, I said I have 4 grandchildren, but it was omitted in this introduction, so. Okay, we can start. Okay, it runs. So mathematical scenery en route between teaching and research. And here I put a picture of scenery in Vancouver, where I live and work these days. So let's start. I cannot see anybody. But I believe you can hear me. Thank you. Okay. So many thanks to the organizers. Many thanks for inviting me here. It is scary to be here in this huge theater, but I'll survive. And many thanks to many of my colleagues who supported me over the years. Here's the beginning. My work as a mathematics teacher-educator. In this work, mathematics and pedagogy are juxtaposed. And in my work, I always seek engagements in which a task with a pedagogical flavor helps teachers extend their engagement with mathematics. Part of my job is to extend teachers' personal mathematics and connect their knowledge of school mathematics with mathematics learned at the university. But I'm also a mathematics educator, researcher, and research is also juxtaposed with my mathematics and pedagogy. And part of my job is to explore teachers' and learners' mathematics and also teachers' pedagogy. But big part of my work is my personal engagement with mathematics. For example, recently in my class, which was a methods course for prospective elementary school teachers, I asked them to divide given region into 4 equal parts. So some were like obvious ideas, but my goal was to present something like that and discuss what is equal and what is equivalent, and then some unusual solution was given to me, which rather than dismissing the solution and saying, okay, that's how it works, I engaged in my personal mathematical problem solving, how to divide the circle into 4 equal area parts using 3 parallel chords. So it is too dark maybe for you, but I think that maybe you would like to solve it. It is not as easy as it appears. Okay, but I will tell you stories. And I already... So my first story is what is scripting or script writing in mathematics education and how it emerged. The first part, what is scripting, is an easy part because according to the Oxford Dictionary, script is a written text of a play, movie, or broadcast, and I extend this definition in the context of mathematics teacher education, and I consider script as part of a lesson or any mathematical interaction as it is construed by a script writer. So in short, in my research, which is part of my data collection, teachers create scripts in the form of a play. Teachers write a dialogue of their imagined interaction between the teacher and her students. How it emerged is a longer part of a story, but here it's my favorite quote from John Mason. That's how it started, that most frequently there's some form of disturbance which starts things off. Disturbance, that's what started things off for me, and that's how it started the development of what I call scripting task. So what kind of disturbances led to the development of scripting tasks? It was my personal dissatisfaction with lesson plans, and it was difficulty for my students who are prospective teachers to pretend. For example, I would ask them, how would you explain this to a student? And they would say, I would do that, I would show that. And I used to sort of kneel down and pretend that I'm shorter and say, please talk to me as if I were your student. And teachers had very much of a difficulty doing this. So we developed what we called initially lesson play, and I use here the word play here in theatrical connotation, like a play by Shakespeare or others. So in teacher education, there is our continuous struggle is how to support and improve teacher development. And the fundamental issue in working with teachers is to resonate with their experience so they can imagine. And I emphasize the word imagine themselves in doing something in their own situation. So this idea of imagination leads to the idea of role play. So what is role play? Role play is a behavior as if you are a particular person in a particular situation. And research on role-playing lists many advantages. It is increased interest, empathy, and many other good things that research shows that people achieved when they were engaged in role-playing. But role-playing also has very, very big disadvantage, and it is time and participation logistics. So how to give all students an opportunity to participate? So here I get to imagined role-playing or script writing. So you do not act out a play, but you write it down as you imagine it unfolding. So I was very happy initially with this idea, because teachers write dialogues, and I decided that writing dialogues, it was a wonderful idea, my wonderful idea. But then I thought that some other people used this idea before me, and okay, there is nothing new beneath the sun. So yeah, you recognize some of those guys, Socrates, Galileo, and people here are familiar with the proofs and refutation of Imre Lakatos, and some contemporary colleagues in mathematics education used script writing, used dialogue writing, even when they didn't call it, scripts. They used dialogues in their research and in their teaching, but okay, nothing new under the sun, but here we come. Maybe there's still something to contribute. So that's what led to the development with my SFU colleagues, Simon Fraser University colleague, Natalie Sinclair and Peter Lildal, got to the development of this idea of lesson play in mathematics education. And then we received some critique from colleagues because they said that interaction does not have to be in the form of a lesson. Anyway, so I said, part of development of this scripting or initial lesson play idea is because of dissatisfaction with lesson plan. And because today, with a click on the button, you get lesson plans on every possible topics. And there are many advantages for good lesson plans. So students can engage in the activity that is appropriately chosen, there are clear organization, and many other good things like clear links to student prior knowledge. But there are many things that I would like teachers to engage with and we cannot find in a very good lesson plan is attention to student difficulties and attention to a particular language that the teacher will use in their communication with students. So that's how we went to the idea of lesson play, which is presenting a lesson in the form of a script for a conversation between the teacher and the student. And once again, I mentioned that some critics said that communication doesn't have to be during the lesson, so we went to the idea of scripting approaches in mathematics education, which is presenting an imaginary conversation between a teacher and her students or among students. So there are many affordances to this idea of scripting. For prospective teachers, it is an opportunity to imagine themselves in a situation. Imagine, but without thinking on your feet. Imagine thoughtfully. Imagine when you have time to work through it. For teacher educator, it is an opportunity to scan the behavior of the class in order to support teachers further, to know how they think about mathematics, how they imagine pedagogy. And for researchers, it is a good data to work with, to describe, and then to enhance teachers' knowledge. So it started with when simply told people, asked teachers to write a play, or their plays were not very interesting. They said there was a student incorrect answer. The teacher would look at the class and say, is there some different ideas? Somebody will present a different idea. The teacher will praise this different idea, and the lesson continues. Then we said, okay, write a play that addresses a problem, and we found out that the repertoire of problems or problematic issues for prospective teachers is rather slim. So we went to write a play. We started with prompts. We gave teacher a prompt. There are many different kinds of prompts that I will talk about, but the most frequent prompt is the beginning of a dialogue. So we provide script writers with the beginning of the dialogue, and their work is to continue this dialogue. So which brings me to the second story, which I call, Where Do Prompts Come From? There are many parts in this story, and I will exemplify several prompts, and I will highlight a few research results. I will not present anything that looks like a formal research report, and I will talk in first person plural. I will say we. And it is not because I decided to change my pronouns to plural. It is because I worked with wonderful people in the last 10 years who were postdoctoral researchers, Dr. Igor Kontorovich, Dr. Ofer Marmur, everybody's doctor, Kitty Young, Annie Bergman, Keith Gallagher, Janan Gunes, and Andrew Kircher. So when I say we, it is work with these wonderful young people, and you see they're smiling, almost all of them. So where do prompts come from? Some of them come from popular student mistakes that we faced in our research, that we faced in our teaching, or that I learned about in the literature. They come from student correct claims supported by inappropriate reasoning, and I will exemplify those. Prompts also can present opposing positions. Prompts also come from research, from prior research, or from unexpected student questions. There are also proof scripts and scripting journeys that I will mention towards the end, but I will exemplify the first three, and then I will focus on the highlighted parts now. So here's an example of a student mistake that was used as a prompt for teachers to continue. A teacher said, you indicated that 91 is a prime number, and why have you indicated those? How did you decide? And the student says, it is not in the prime tables, so very popular student mistake, but how teachers had to continue the dialogue. Once again, I said a prompt can present correct answer, but imperfect reasoning. Example of a prompt, why is 37 prime? Because I checked all the numbers, they do not go into it, so look at this. We can look also at students' reasoning. We can also attend as researchers to a particular language that the student is using. Another kind of a prompt is presenting opposing views. For example, Bonnie and Clyde are discussing numbers and their factors. Bonnie claims that the larger number gets, the more factors it have. Clyde disagrees, and the scriptwriter is supposed to continue the conversation. By the way, one interesting result, I said I will not report results, but one interesting result from this prompt is that student decided that the claim is correct, but prime numbers are exception. Here's another example of presenting opposing views. Sorry. Thank you for people who put water here. Once again, it is a conversation between numbers in a certain interval, and Maria said there's always a rational number between A and B, and Pedro said there are infinitely many rational numbers between A and B. By the way, those two claims are equivalent. One, you can assume one and prove the other. One way is obvious, the other one is not so. But I'm not talking about it, I'm talking about a prompt that exemplifies different views. So in this research, we looked at people's ideas of, students' ideas of destiny, and then we decided to explore the same idea with a population of elementary students, elementary prospective teachers, and we designed the prompt, which is in front of you, and it is not about numbers in a given interval, it is about numbers between 6 and 7. So a student claims there is no numbers between 1/6 and 1/7. So our idea was to explore people's ideas of density, but then some unexpected creature appeared in several of the scripts, and this creature is 1 divided by 6 and 5. And that starts, and now I'm talking about research prompts that come from prior research. So this appearance of 1 divided by 6 and a half started what I call trilogy. Trilogy is 3 studies that the results of one, the beginning of one is inspired by results of the previous one. So I'll tell you a story about 1 divided by 6 and a half, but I will not talk about strange appearances of fractional numbers. I'm talking about how prompts emerge from research results. So that's how, this is an example of a script the prospective teacher wrote. So the teacher here claims we cannot have a number 1 over 6 and a half, 1 divided by 6 and a half, I don't know, the symbol was written. The symbol was written, I'm not sure how to read it. Any other ideas? So they claim such a number either it doesn't exist or we cannot have it, I'm not sure who are we here. Here's another example, that the person knows how to interpret this division, this fraction line as division, knows how to convert 6.5 to improper fractions, knows how to operate here. Do you see the cursor? Yeah, you see the cursor. Knows how to operate on division by fraction, and then decides that it is 2/13. So it is not a fraction, but you can turn it into a fraction. Which also lead to our investigation, what is a fraction? Is one fraction line 6.5? Is it a fraction? And we were surprised to find here two definitions in front of you that according to some definitions, it is not a fraction. Because some definitions, and we looked at all kinds of encyclopedias and dictionaries and textbooks, and there are about half of the definitions, this creature will not be considered as fractions because in some definitions, the numerator and denominator have to be integers. So it was very interesting for us to find out, which led to a new prompt where we wanted students to react to this idea, to react to this number. So we put these words, but 1 divided by 6.5 is not a fraction, so it is new research, new group of students responding to this prompt, and they're asked to respond to the idea that it is not a fraction. This is our research question. How do prospective elementary teachers deal with the ambiguity in regard to the concept of fractions, which is invoked by unconventional representation? But some people try to fit their conventional representation, their part-whole ideas, with this interesting appearance of 6.5. So here's an example of a circle divided into 6.5 parts. But what was interesting here for me, and once again, this is one of the results, the research is published, there are many results, but one of the results is a linguistic ambiguity that people use. So it is technically a fraction, but not really a fraction. And the language that we found in scripts that it is a fraction, but not a normal one, it is illegitimate fraction, it is funny-looking fraction, it is inappropriate fraction, it is an awkward fraction. I'm not making it up, by the way. And there are a few scripts that called it middle fraction, and this idea of middle fraction led us to another research, to another script for another group of students, as is it in the middle? So we developed the following script where a student says 6.5 is exactly in the middle between 6 and 7, so 1 divided by 6.5 should be exactly in the middle between 1/6 and 1/7. So we presented this script, we presented this prompt to now it is a group of secondary school teachers, and we wanted them to continue the conversation. So how I think about it, is there a fraction? Is it exactly in the middle? So of course it can be found during using brutal force. One can calculate the middle, or one can compare the difference between this creature, 1 divided by 6.5, and other fraction. Or you can simply think about this function, which is not linear, and therefore it is definitely not in the middle, but how did people react it? How did people respond it? Once again, this is our research question, how non-traditional representation shape their responses. And here we used what we call attribute substitution. So attribute substitution refers to the cognitive process in which an individual unwittingly thinks about related attributes of an object or concept instead of the one which is under direct scrutiny. And we use attribute substitution all the time in our life, not only in research. For example, I asked a person yesterday or 2 days ago at a reception, I asked a colleague, would you like a glass of wine? And she responded, I just had one. So she didn't answer my question. I wanted her to know whether she had a glass of wine. So this is the idea of attribute substitution, answering but not answering the question. In mathematics research, it is used, attribute substitution is usually used in research in probability when people decide that the sequence of head, head, tail is more likely than the sequence of 5 tails. And once again, people substitute the attribute. They don't see this particular sequence. They see the sequence of 3 heads and 2 tails. And when you interpret this sequence as all the sequences that have 3 heads and 2 tails, it is. Then indeed their consideration that it is more likely is correct. In our paper, we looked at different idea. I didn't talk about wine. I talked about conversation about a mother and son. Do you help with your math problem tonight? And the son says it is not due till Friday. So it is another example of attribute substitution. So where did attribute substitution appear in our research? That people did not address the particular question. People did not address the particular claim of whether this number is exactly in the middle between 2 fractions. They addressed in their scripts looked as if different questions are addressed. Some focused on prerequisite knowledge, some focused on number representation, and some focused on finding what is the middle between 1/6 and 1/7, and very few focused on why isn't 1 divided by 6.5 is in the middle. So, but I would like to share with you some, what we call appropriate example is where a person responded to this prompt, used analogy. He said, if 1 divided by 6.5 is exactly in the middle, then 1/3 would be exactly in the middle between 1/2 and 1/4, and showed with manipulatives that this is impossible, that this would be wrong, and from here extrapolated. So this is end of my story of trilogy, how results emerged, how results from one research lead to the next research. So I focused on identity, and then I focused on a particular number, 1 divided by 6.5, and then our research focused on the middle between 2 fractions. And this is the end of this trilogy, and going back to the prompt. So I would like to show examples of unexpected student questions. One of the unexpected student questions that we presented teachers, secondary school teachers, is what is geometric about geometric sequences? You call these sequences geometric, but these are just sequences of numbers. And students had to develop a script in which conversation between teacher and students continues this prompt. So why I call it unexpected? Some things we are used to. Sometimes we learned about geometric sequences. We used to calling them geometric, and we don't actually bother lots of time why this name and how this name emerged. For example, when we see glaciers, we ask why glaciers are blue, or some of them. But not much less often we ask why the sky is blue, because this is something that we sort of got used to from very early years. So, leave glaciers, back to geometric sequences. These are sequences with a constant ratio. And the research question was what arguments are invoked by teachers to explain the adjective geometric in reference to a geometric sequence. There were different types of arguments, and I will focus on one most frequent one because it is called geometric because of the relation to the geometric mean. Why it is most frequent one? Because mostly if you Google why geometric sequences are geometric, most of the responses will use geometric mean. So to remind you, this is geometric mean on the right and arithmetic mean on the left. That's how we compose geometric mean. So if students presented geometric mean and explained, when a teacher explained the geometric mean, the nth element of the in the geometric sequence, the nth element is the geometric mean. So does it explain? Some people said it doesn't answer the question. So actually nobody was happy with the answer. Teachers wrote, different ideas about this name, but their students were unhappy. Their student characters were unhappy, with sort of signals that writers themselves were unhappy. So here's from a student: I'm not sure why this is considered useful. Why would we ever be in a position where the nth element is unknown, but its two neighbors are known? So connection to geometric mean, okay, let's involve geometry. Let's involve geometry. So geometric mean is you have, suppose you have A and B are the length of two sides of a rectangle. So the geometric mean, root of AB, is the length of the side. So this is the connection to geometry. Isn't it wonderful? But also there is a connection to geometry in arithmetic sequences. So students presented more of a confusion why geometric sequences are called geometric and arithmetic sequences are not. And arithmetic sequence, they also interpreted geometrically arithmetic sequences and suggested to call it additive sequences versus multiplicative sequences, and were very unhappy. The student characters were very unhappy with any explanation that the teacher character put forward. So I can quote here Humpty Dumpty and say, when I use a word, it means just what I choose it to mean, neither more nor less. Or I can present a different quote that some mathematician had said that the true pleasure lies not in the discovery of truth, but in the search for it. So students learned something. They searched, they wondered, they explored. They couldn't find exact solution on the internet. And they learned lots of new mathematics for them, such that continuous proportions from Euclid's and some other things. So this is the value of this exercise. You explore a sentence, you explore some issue, and by that you become more enriched mathematically. Okay, so here's another example of unexpected student questions. This is one of my favorite examples, one of my favorite examples, one of my favorite research studies ever used. It is about exponent -1. A student said that it means 1 over, right? So, but f with exponent -1 stands for an inverse function. So a student asks, is it the same symbol or what? And once again, teachers had to continue the dialogue. So yes, it is the same symbol. It stands for an inverse, either in multiplication or in composition of functions. But here's something very interesting about the English language. In English, with respect to numbers, it is not called inverse, it is called reciprocal, which probably one of the sources of students' confusion, because some people didn't see, I thought that students will either invoke a group theoretic perspective, that it is exponent -1 stands for an inverse in the group structure, or they could invoke a different perspective, that it is a homonym signaling different context-dependent interpretation. But what was interesting, that they invoked what is called in linguistics polysemy. It is the same symbol, different related meanings. So I will go quickly to this one. Here is a focus on similarities. The idea of inverse is not called like that, but it is invoked by saying in both cases we go back to the starting point. And some person confessed that personally I kept the idea of different rules applying to numbers and functions when dealing with inverses. It was not until university mathematics did I reconcile the two ideas in one overarching idea of an inverse. So here's also an opportunity for a teacher educator to extend people's mathematics and to maybe help them look at what is similar or what is the same, rather than focus on differences. Because in research, there was very little attention to a group theoretic perspective, to the same idea of inverse, even for people who were familiar with group theory. What do I mean familiar? They took a group theory course, but they didn't invoke the related knowledge in this particular context. So what is going on here? Poincaré said that mathematics is the art of giving the same name for different things. But here, when considering 5 with exponent -1 and function with exponent -1, reciprocal and inverse, maybe this is different name for the same thing. And it is something very peculiar in English, because with the help of Google Translate, I looked at several other languages. I don't speak all those languages. I don't read all those languages, but I can definitely recognize the same symbol or the same sequence of letters. So what you have here in front of you is Polish, Ukrainian, Finnish, Korean, and I believe some idea of Chinese. So if we change the prompt and I say, actually the teacher says there is a peculiar connection, just pointing to the idea that there is a peculiar connection helps people search for such a connection. So about the peculiar connection, so yes, when I used, with a different group of students, when I used modified script and the teacher said there is a peculiar connection, people were willing to seek such a connection and invoke the idea of inverse in both situations, but they had to be pointed to this connection. Which brings me to my personal experience. A student asked me some time ago whether asked me whether I'm familiar with the relationship between a tangent, which is a trigonometric function, and a tangent line. And I looked at her with some question mark, and I said, really? There is a connection? My first reaction was, oh, but it is not the same word, it is not the same spelling. But if you look at it for a moment, yeah, there is a connection. You can look at similar triangles and the unit circle, and the connection becomes obvious. So my question is, and I blame the students for not recognizing the connection, not blame, but I was concerned that they have not recognized the connection, but I haven't recognized the connection until somebody pointed it out to me. But I have an excuse, and it is a language excuse, because in the languages of my mathematics education, there are 2 different names. There are 2 different words. Okay, so back to the story, where do prompts come from? There are also proof scripts where we present a proof to a student, and the teacher is supposed to question the student and have a conversation with the student where they ask about each line of the proof and see the script is written to checking students' understanding of a particular proof. So this is another way of writing dialogues. And a new way, which we employed rather recently about writing dialogues, we called it scripting journey. And in a scripting journey, participants record as a script their experiences in a mathematical investigation. It is similar to a problem-solving journal, but people write it, present it as a dialogue when they solve a problem in a group, and then they record their journey, their problem-solving experience in the form of a dialogue. And this is one task that we used recently and asked people to report on their investigation in the form of a scripting journey. So here's the task in front of you. Another example that we use the dialogue is some older research. We use the idea of visual duoethnography. Duoethnography is a research methodology in which 2 or sometimes more researchers converse about the experiences in their lives that revolve around some topic and expose their understanding from different perspectives. So we asked students to write a dialogue in which a student of Euclid and a student of Goldbach discussed their theorem of infinity of primes. And these students of Goldbach and Euclid, they met in heaven, and they had a conversation about their understanding of a particular problem. So virtual duoethnography is another way of involving students in writing dialogues. So maybe the next thing of the agenda is asking people to write a dialogue about Newton and Leibniz, who discuss infinitesimals. And this ends my stories, but it doesn't end my presentation yet. So I started by saying that there is nothing new under the sun, but I seek novelty, and maybe this novelty is not under the sun. It is a novelty in my personal understanding of mathematics and in understanding of mathematics of my students. So at this moment, I want to acknowledge the late Professor Ulrich Ron and his influence. He was my PhD supervisor, and I want to acknowledge his influence that was crucial in my engagement with mathematics within mathematics education, research, and teaching. And I also want to acknowledge Dr. Rina Zazkis, who helps me sustain my engagement with mathematics within mathematics education research. So, conclusion, or maybe you will walk out this theater and the colleague who was too jet-lagged to come here will ask you, what did she say? Or did she say anything interesting? Did she say anything important? Or what have I missed? That's what people usually ask. So I prepared the answer for you. So you can say that writing a dialogue or script writing is a powerful approach in teaching and research, and that it is always possible to enhance a person's mathematical knowledge to understand better what was previously well understood. And it is my plea to researchers and young researchers, so do not forget mathematics among other very important topics, whatever it is, where it is Casio, calculators, or social justice. Do not forget mathematics among other important topics of interest in your research. So thank you very much.
Thank you very much. Before comments or questions, let me say that this was a fantastic lecture, a fantastic lecture.
Thank you.
Okay, so we have some minutes for questions, comments. I have been thinking that maybe for us to have more people participating in this questioning, shall I ask you to try to have the tweet style, which is about 140 characters per question? Could that be possible so that we have more questions? Thank you. I really don't see.
Thank you for your presentation. And yeah, I think it's good to keep the math at a focus for research. I just want your comment around that kind of inappropriate reasoning in that question about factor of 37. So you know that what kind of rule of thumb people often look up to the square root of that number to find if they are factor. So people can try any kind of number from 1 to about 6, like square root of 37. So can you comment on why inappropriate for that kind of reasoning? Thank you.
I'm sorry, I totally missed it.
Yeah.
I don't know where it's like, I'm happy to continue this conversation. I didn't get the idea of a square root, sorry. Anyway, there is no break in the schedule, so maybe it is okay to have 5 minutes break.
Hi. Thank you for the great lecture. I'm just wondering, what do you think about AI's role in script writing? Is it potentially useful or useless? What would AI say if the Why is the geometric sequence called geometric?
The AI told people to look at geometric mean, because many of people tried. But have AI to write scripts? When I started this research 10 years ago and even 5 years ago, AI was not there yet to that degree. But today, hey, it is a wonderful research agenda. Let's do it.
The idea of a mean of two numbers is that could the two numbers be the same? So in arithmetic, when you add them, they are one-dimensional after each other. Whereas in geometry, when you multiply them, they are two-dimensional. And the moment you multiply two numbers, you have a square or a rectangle. Doesn't that give the answer to why it's called geometric and arithmetic mean?
Yes, it is a possible answer, and some of the students did invoke this idea and invoke the idea of dimensions. Once again, I have not reported of all the research results, by the way it is published. I just pointed out to what I found most interesting in some of the approaches. And once again, none of the ideas that teacher characters brought forward, student characters were satisfied with.
Thank you for the wonderful talk. I'm interested in your examples of scripts and in different categories. Where do they come from? From your team, the young gentlemen and women, or from school teachers? Where do you get the script? The original one, the revision, deletion, and inclusion? Thank you. Examples, your example.
Once again, I demonstrated examples of prompts that we developed as a research team. And the scripts, students write the scripts. Those students are prospective teachers or in-service teachers. And anybody who agrees to write a script is welcome to write it and share with me.
It's my turn, right? Yeah. Thanks, Professor Zazkis, for your presentation. And I think written first, on the page you say there is a word that may be the Chinese or inverse or reciprocal, but it's not Chinese, it's Japanese. Yeah, I'm Chinese, I know it. Okay. My
apology, but Ukrainian was Ukrainian.
Oh, yeah. Actually, my question was about when you mentioned that in some languages, tangent and tangent line are the same, but in some languages they are not. I wonder if there is a cultural underlying that the words come from different origins in different languages, which reflects the culture of this group of people, how they perceive this kind of mathematical ideas. Yeah, thank you.
Yes, it is a wonderful idea, once again, but my research is not historical research, but it is a good idea to pursue. And there are actually some research done by a person named Park, I don't remember the first name, where in some of the Asian languages, she talked about the derivative function, with a derivative at a point, which is different in some languages and the same in some other languages, and she showed that students who can make the connection then have difficulty to differentiate between these two ideas. So some research was done, and more research is always welcome.
Good morning. Thank you very much. That was very informative. And when you have a class of teachers or pre-service teachers that you work with that are multilingual, how do you approach creating a common language for instruction in terms of the terminology that's been pointed out already, so that there's a unified understanding of the terms included in the scripts?
It is a hard question because I'm not sure how to answer, but my students speak English, my teaching is in English, and whatever their cultural background and whatever their linguistic background, they all have English skills, to the degree of proficiency, to be students at the university and to be teachers in the classroom. So regardless of this background, they respond in English. But as I noted, their cultural, linguistic background can play a role. And it is curiosity, I didn't want to bring it, but people who recognize the idea of inverse, they were not Canada raised. They were not Canada educated. They came from somewhere that I suspect, at least in one case from Romania, that I suspect that the inverse was part of the linguistic connection for these two concepts for this particular student. I think we need a break because.
Okay.
What?
I guess this is not for me. This is for you. Thank you very much.
Thank you very much. Thank you very much. It will fit in my carry-on.